This is physical science. So today we will be discussing about Newton's laws of motion. Okay? Newton's laws of motion. Alright? So pag sinabi nating laws or laws of motion, di ba? These are generalizations or statements that govern the behavior of moving objects. So, di ba? Parang pag law, yung batas natin, our government laws, di ba? They are generalizations that really help us govern our society. Okay, so dito naman about the behavior of moving objects. Hindi naman para i-direct sila, but ito yung mga really statement that describes what's going to happen if this one is changed, or if this happens, what's going to happen, things like that. Okay. All right, so with that, let's start with the first law of motion. And the first law of motion states that a body or an object at rest will remain at rest, okay? And a body or object in motion will remain in motion at constant velocity. And when we say constant velocity, it is a constant speed in a straight line, and it continues that way, stays that way, if no net force acts on it. Okay? In other words, in the absence of any interaction with something else. Okay, so what's responsible for an object to remain at rest when it is at rest? Or what's responsible for an object to remain moving at constant velocity if it is moving at constant velocity? Okay? So it is inertia. O, sabi natin, inertia is property of a body that describes its resistance. Okay? So, nire-resist kasi. Okay? To change its state of motion. So, if it's stressed, because of inertia, it remains at rest. Alright? Okay. And if it's moving, it remains moving. Okay? Because of inertia. And sabi natin, inertia is a property, but although it's a property, we really cannot quantify it. But what gives rise to inertia is the mass of objects. And it is the mass that can be quantified. So we say mass is a quantitative measure of inertia. All right? So that's all about mass. Okay? So, sabi natin kanina, unless a net force acts on it. Okay, so actually, what is needed to change an object's state of rest or uniform motion is a net force, not just a force. Because although force is an influence that can change velocity of an object through the push or pull, okay, so it's actually push or pull, okay, horizontal or vertical, whatever, okay, basta it's force, all right? But then again, if the force does not exceed the inertia of the object, then there's not going to be a change. Okay? Yan. Kaya ang pinag-uusapan natin dito is net force, unbalanced force. Okay? Yan. So, the applied force must exceed the inertia, okay, in order to cause an object that is at rest to move. Okay? Or in order to cause a moving object at constant velocity to change its velocity. Okay? Kaya sabi dito, net force or unbalanced force is what is needed to cause a change in velocity, because balanced forces have no effect on an object. They just cancel out one another. Okay? Kasi, yun. Parang, if an object is at rest, even if you push it, okay, if the inertia of the object is enough to counter that pushing force, then it's not going to move. O, yun yung ibig sabihin nun. So, that net force must be something that will exceed the inertia or the resistive power of the object or the resistive force of the object. Okay? Yan. So that is Newton's first law of motion, and it describes that inertia is the one responsible for an object to remain at rest or moving at constant velocity. Okay? So yan. Now, Newton's second law of motion, di ba? If, for example, there is a net force that can change the velocity of the object. Okay, at rest siya, and then the net force is enough to make the object at rest move. Okay, so from rest to motion, o di ba sabi natin, there's a change in position, may motion. So if there was a change in the velocity from rest to motion, okay, so may initial velocity at may final velocity, and that has been measured over a certain period of time, it results to acceleration. Sabi natin, di ba, before? Okay, so second law of motion says that the acceleration of a body that is acted upon by a force is proportional to the magnitude of the force and inversely proportional to the body's mass. Okay? Ibig sabihin, the greater the force, the greater the acceleration, and the greater the mass, the lesser the acceleration. Okay, so force and acceleration, they're proportional. Okay? The greater the force, the greater the acceleration. Then why is it inversely proportional with mass? Diba? So, ibig sabihin, the greater the mass, the lesser the acceleration. Simply because Newton's first law of motion says that inertia is responsible for an object's resistance to change its state of rest or motion. So the greater the mass, the greater the inertia. So the greater the resistance to the force. Okay? Kaya it results to lesser acceleration. Okay? That's the reason for that. Now, we described acceleration here with in relation to mass and force. But what about force? Okay, kasi dito do sa first law of motion, it said that it is a net force that will cause an object to tawag dito, to change its state of motion, or in other words, it is a net force that is responsible for a change in velocity. Kaya nga dito sabi dito, the net force acting on a body is proportional to the mass of the body and to its acceleration. So ibig sabihin, if there's a great acceleration, there was a great net force that acted on the body. Okay? And of course, if there's a great mass, okay, greater mass, you need a greater net force to accelerate it. Diba? Yan. So, as far as net force is concerned, okay, the greater the net force, the greater the acceleration. And of course, because of a greater mass, you need greater net force to accelerate it. Okay? So, in equation, or the relationship could be expressed this way. So the net force is equal to the mass times the acceleration. In symbol, we have F equals M times A. Okay? F times A. Ayan. So where force, F here is the net force, M is the mass, and A the acceleration. Okay? Alright. So second law, therefore, gives a relationship of an object's acceleration with its mass and to the net force acting on it. So yun yung binibigay ng second law of motion. Also, the second law explains the behavior of moving objects, and it gives us the link between the cause and effect. Okay, so it links the cause and effect, okay, in a definite way, sabi nga. So the cause is the force, and the effect, of course, is the acceleration. All right, so in a definite way, sabi, so that means we can actually measure it, we can quantify it. So that is why the Newton's second law of motion also describes problems involving force and motion. Okay, so yun. So with that, what is the unit of force? Okay, sa SI system, the unit of force is the Newton. Okay, and it is the force. 1 Newton is the force which, when applied to a 1 kilogram mass, gives an acceleration of 1 meter per second squared. Okay? So, yan. F equals ma. Therefore, okay, 1 Newton equals 1 kilogram meter per second squared. Right? So, that's the relationship of force with mass and acceleration. Okay, so let us have sample problems to illustrate yung ating Newton's first and second law of motion. Number 1, a 10 kilogram body has an acceleration of 5 meters per second squared. What is the net force acting on it? Okay, so with our formula, F equals ma. That is also our working equation because we're solving for F. Okay, and substituting the value for mass, which is 10 kilograms, and acceleration, which is 5 meters per second squared. Solving that out, we get 50 newtons. Okay, another example. A force of 80 newtons gives an object of unknown mass an acceleration of 20 meters per second squared. What is its mass? So this time, it is mass that is being asked for. Okay, and still, with our formula F equals ma, we can rearrange it to come up with a working equation na m equals F over a. Okay, and substituting the values given, we have 80 newtons divided by 20 meters per second squared. Our final answer is 4 kilograms. Okay? So, let's continue. Weight. Weight, sabi natin, last time, is a property that is common to all matter. So, ibig sabihin, it's one of the general properties of matter. Okay? Kasi merong mga distinct properties na pinag-usapan natin before. But, weight is general. Ibig sabihin, all matter has weight. But it is not just a property, but it's also a force. Okay, what kind of force? It is a gravitational force. Okay, so the gravitational force with which the earth attracts an object. Okay, so yun yung force that causes an object to be accelerated downward with the acceleration of gravity. Ayan. So kung dun sa second law, force F is the net force that will cause an acceleration A for an object of mass M. Now, dito naman, weight is the force, okay, that causes an object of mass M to be accelerated downward with the acceleration of gravity, that is G. Okay? And that is why near the Earth's surface, G is constant. And with that, let's take a look at these relationships. Okay? So this one is analogous to F equals ma is analogous to W is equal to mg. O kasi if A is the acceleration caused by the net force here, now G here is the acceleration due to the weight. Okay? Yan. Which is the gravitational force. So, if A is G and then F equals W, then we say A is equal to mg. And so that is why G has a constant value of 9.8 meters per second squared, or simply, or 32 feet per second squared. All right, so those are the two values because 9.8 meters per second squared is the SI value for G, and 32 feet per second squared is the English or British value, okay, for G. Right? So let's take a look at this table. So this gives you formulas to solve mass given the weight and to solve for weight given the mass. But here on the table, you are given the formulas both in the SI and in the British system. Okay, so yun yung mga systems of measurement. Kasi di ba sa SI, we have meter, kilogram, centimeter, yon. O sa mass, kilogram. And distance, we have meter or centimeter, kilometer, di ba? And then for the force, we have the Newton. Okay? And for the British system, the mass is expressed in slug, the force in pounds, okay? At yung mga iba pang measurements nila like distance, it's expressed in feet or in inch or in miles. Oh, yun yung mga yon. Okay, so this table then should guide you on deciding when to use 9.8 meters per second squared or 32 feet per second squared for G. Okay? For the value of G. Okay? Ayan. Alright? So, that's it. Now, let's have some sample problems to illustrate mass and weight. Number 1, what is the weight of an object whose mass is 50 slugs? Okay, dali, ano? So weight equals mg, substituting the values given in the problem, solving out. Okay, so why did we use 32 feet per second squared? Because the mass is expressed in slugs. So now you see the guide there, when to use 32 or 9.8 meters per second squared. Okay, so solving out now, we get 1,600 pounds. Okay, all right, another example. What is the mass of an object whose weight is 50 pounds? Okay, so again, ayan. So from weight equals mg, we derive the working equation na mass is equal to W over G. Substituting and solving out, we get 1.56 slugs. Let's continue. Moving on, let's take a look at third law of motion, or Newton's third law of motion. It states that when one body exerts a force on another body, the second body exerts an equal force in the opposite direction on the first body. What does that mean? It means that in every interaction, there is a pair of forces acting on the two interacting bodies. Okay, so there has to be two objects interacting with one another. Okay, and with that, we can state another way that the third law of motion states that forces always come in pairs as a result of mutual interactions. So, laging may force pairs basta merong interaction. Okay? And what are those force pairs? Number 1, we have the action force. This is the force exerted by an object on another object. And then the reaction force, this is the force exerted by the other object on the first object. So you see, these are force pairs that that act on two objects, not on just one object, but on two different objects. Okay? So yan yung force pairs. And sabi natin, it is a result of mutual interaction. So what are those interactions? Okay, so the interactions, number 1, we have the contact force. Okay, so this is a force applied to a body by another body that is in contact with it. So dito makikita nyo, a prerequisite for it to be called contact force is that the two objects should be physically in contact with each other, di ba? Okay, so it results from contact interactions. All right? So examples of this are normal force, friction force, tension force, pushing force, di ba? Yun. So yun yung mga examples of contact force. The other one is non-contact force, okay? So it acts on an object without coming physically in contact with it. So ibig sabihin, even if the two objects are not touching each other or far apart from each other or away from each other at a certain distance, meron pa ding interaction. So kung may interaction, meron pa ding force pairs, di ba? So it comes from action at a distance interactions, okay? So examples of these are gravitational force, electrical force, magnetic force. Ayan. So those are the interaction forces. Okay? So let us have a picture here to illustrate kung ano yun. So here we have a flower vase that is seated on top of a table, okay? Or on top of a table, okay? Now, even if it's just resting there, okay? There's still a force acting on it. Remember, it has weight, okay? And that is the one that is directed downward here. So that is the action force. And the table, the reason why the vase is not continuously, okay, falling because of its weight, all right? Oh, kasi may pull of gravity, di ba? Because there is a reaction force that counters the action force of the vase, and it is exerted by the table on the vase. Okay? So remember, the action and reaction forces are equal to each other but opposite in direction. Okay? All right. So that is why they cancel out talaga eh kasi nga equal and opposite, 'di ba, in direction. So let us illustrate those forces into a free body diagram. So a free body diagram is a diagram that shows the different forces acting on objects and the directions in which they're going. Okay? Yun, yung mga iba't ibang directions. Okay? So for this force pair, this is its body diagram. Okay? So remember at the origin, okay, yung mga tails ng arrow ang nilagay doon to start. Okay? Yan. So kaya nga yung downward, itong downward na to, ito siya, itong downward na ito. And that is the force exerted by the vase on the table. Okay? Yan. Yan yung action force. Okay? And then upward is the reaction force exerted by the table on the base. Alright? Yan. Okay, so this is just an example. Let me give you another picture so that you'll have an idea na hindi lamang isang force pair ang meron sa isang situation. Okay? So take a look at this. Ayan. Alright? So parang kamukha nung ating flower vase on a table. Ito nga lang ay book. Okay? So the downward arrow here is the force of the book on the table. And the upward arrow is the reaction force of the table on the book. Okay, so here, the downward arrows here are the forces of the table on the floor. And the upward arrows there are the reaction forces of the floor on the table because they are in contact. O yung paa nung table is in contact with the floor. Okay? And here, the book is in contact with the table. So these are examples of contact forces. Okay? And you see where the force pairs are. Alright? Okay, so with that, we're now ready to take a look at some sample problems. Now, in our sample problems here na ibibigay ko, is not just specific for one concept, but could be a combination of the various motion concepts na diniscuss natin from the start, okay? Hindi naman lahat-lahat, but a few together, okay, or some together, okay? Alright, so siguro, let's take a look at the example para makita nyo yung ibig kong sabihin, okay? So number 1, a 2 kilogram block A and a 3 kilogram block B are in contact on a frictionless table. Okay? A horizontal force of 10 newtons is applied to block A. Find the force with which B resists the pressure of A on it. Okay, so here is a picture of the problem. Without the horizontal force here, the interaction would be between block A and the table. Okay? Or between block B and the table. Kung table yan or kung floor man yan, kung ano man yan, surface na yan. Without this horizontal force, okay? There would be no interaction between A and B. Nakuha nyo? But there, yun, because by virtue of the weights of A and B. Okay, but then, remember, dito sinabi sa problem na the table, it's assumed to be frictionless. Para the applied force, okay, will just be evaluating the action and reaction forces between block A and block B. At hindi na natin i-consider yung opposing force due to friction, okay, which opposes the applied force here, okay? O kaya isa lang, in-assume natin. Kasi evaluate lang natin yung action and reaction force between A and B as force is applied. O kasi kung wala naman yung force na yan, walang interaction between A and B. Alright? So if that is a pushing force, okay, na-push siya, then there is acceleration. Kasi from rest, nag-move. Tama? From rest, nag-move. Okay, so with that, we say F equals ma. And to get the acceleration of both block A and block B, we have here A equals F over m, substituting, and then remember that it's the total mass of the two kasi the force applies to both, okay? And they will have the same acceleration anyway because they are in contact with each other. Alangan namang pag pinush mo itong A, mas mabilis yung motion niya kaysa sa B, di ba? Of course not. They have the same acceleration, which is 2 meters per second squared. Okay, now, to give block B that acceleration of 2 meters per second squared, the force that A exerts on B must be the mass of block A multiplied by the acceleration. Okay? So if that is the force exerted by block A on B, then the force exerted by block B on A is the same. So that is why here we have F of block B on A is equal to the F of block A on B. They are equal, but the negative sign here indicate that they are in opposite direction. Okay? So solving that out, we get negative 6 newtons. So in other words, the action force exerted by block A on B is 6 newtons. Okay? Yan. Tapos yung B on A is negative 6 newtons. Okay? Now, to indicate that it's in the opposite direction. Right? Let's have another example. A net horizontal force of 4 newtons is applied to a car at rest whose weight is 10,000 newtons. What will be the car's speed after 8 seconds? Okay, very clearly, the problem is asking for the final velocity of the car, okay, after moving from rest after 8 seconds. Okay, so our formula is V sub F minus V sub I is equal to 80. But since the car started from rest, our V sub I is 0. So our working equation now is V sub F is equal to 80. But look, we need acceleration to solve for the final velocity kasi given naman na yung time, which is 8 seconds. But the acceleration is not directly given. Instead, the horizontal force is given, which is 4,000 newtons. And from there, according to Newton's second law of motion, F equals ma, and using this formula, we can have an equation to solve for the acceleration, right? Okay, but then again, continuing, mass is not directly given. Instead, you were given the weight. And we know that from weight, it is equal to mg. And using that formula, we can derive an equation to solve for mass, which is this one, W over G. And substituting, okay, and solving out, we get 1,020 kilograms. Okay, so this is the mass. Okay, so we can use this now to use this equation to solve for the acceleration that we need in order to solve for what is being asked in the problem. Okay? Ayan. So with that, we can calculate for the acceleration, substituting the values, the solved mass, the computed mass, and the given force, okay, in the F, right? And solving that out, we get 3.92 meters per second squared, okay? And with that, we're now ready to solve for the final velocity that is being asked by the problem, okay? So substituting the values obtained and the value given for t, solving that out, we get 31.4 meters per second, okay? So nakita nyo, class, the interplay of formulas, okay, the strategy on analyzing and solving a problem, okay, where instead of directly giving the needed data, you were given another data, okay, and from there you can calculate the data that you need, okay, just like what we did in this example. All right. Okay. So with that, okay, that ends our discussion for Newton's laws of motion.